Alright, hell yeah. This was supposed to be a fast video. It wasn't. We made mistakes, but it's pretty decent. Hell yeah. Alright, hell yeah. So today we have linear algebra, and we have another LU factorization problem. I got food on the stove, and it's the only way that is going to get me making shorter videos. So I think we got 20 minutes. If we were able to do this in 10, that would be very surprising. But what I'm going to go over is just my method that I was using at the coffee shop, where I just don't lose my mind. I can get kind of to the answer fast. And so the general gist is that we have something like this. This is the coefficient matrix, this is the matrix of unknowns, and this is the matrix of constants. This is very similar to just 2x plus y is equal to 3, and then x minus y is equal to 1. This would be like 2, 1, 1, negative 1, and then x, y, and then 3, 1. And I think that's very important for me to do every video so we're not just losing our minds. This is, you know what I mean? And to get a solution, we want this matrix just to be, you know, this is the matrix of solutions. You know, they're just going to be individual values. And that's going to take the form of the inverse A times matrix B. And why is that? Is because we're going to have this, and we're going to take the inverse of both sides. And when we do this, this becomes the identity matrix, and so sweet. So now what we have is A, we're going to separate into a lower and an upper. And if we do that, a lower and then an upper, they're going to look like, the lower is going to look like that, and zeros on top. The upper is going to look like that with values and the 0 on the bottom. This is equal to A, and we want to find the inverse of this. The inverse of this is going to be the equation inverse U, inverse L. And the reason it is, we want to do that proof, I think that proof is very useful. It's because if we are saying this is the inverse, then LU times the inverse of LU has to be the identity matrix. And we're going to say this is LU, and we're going to assume that this is that these are the same. And so we're going to put inverse U, inverse, and we can do associative properties. So we can see that's the that's the identity, and then the identity times the matrix is just the matrix itself. So this goes away, and we can see that this is the identity. So that's the very quick proof. Okay, hell yeah. Once we get, and then how do we, like, so I'm going to get a lower and then an upper, but this says to get the inverse, I need the inverse of an upper, inverse of a lower. The inverse of any matrix, just a general matrix, is going to be 1 divided by the determinant of that matrix times the adjoint of that matrix. And the adjoint is the cofactor transposed. The cofactor transposed is the minor of all the locations, but with a sign change, either positive or negative, whether it's in depending on what row and column it's in. If the row, like row 1, column 1, if these add up to a positive number, then there is no sign change. If so these will have no sign change. Those 4 will have a sign change. So that's kind of the general gist. And hell yeah, how long did that take? You know what I mean? So that took 4 minutes. So not bad. All right, so now we're going to go through how I'm going to do this. And then I'm going to, on my page, I'm going to put because when we do Gaussian elimination, we're going to get zeros here, and then we're going to get an upper. And then we're going to, whatever we do to get the upper is going to form the lower. But I'm going to put the lower over here. So I'm going to do 1, 2, 3. And this is also very useful for me to do some dots, just so I know like how much space I want to use on the page. Alright, and then so I'm going to put this. This is going to be my lower, you know what I mean? Like we're taking A and we're making it into an LU. So this is the L part and this is the U part, and if I multiplied these two together I would get the A. So we can do a little double check after we get the lower and the upper. But the upper is typically what we want to, you know, I mean, you just use Gaussian elimination. You can just write this first row. And then I want to, well, that's not 100%, you know what I mean? You might need to get the first row to have a 1. This problem, the first row is just 1. If you had to multiply the first row, let's say the first row was 2, 4, 6, and you had to multiply, and you wanted to multiply a 1/2 times the first row, then this identity would be multiplied by the reciprocal of this is 2. So I would take this 1 and then multiply it by 2. We will have that property come up in this problem. So, but hell yeah, this one's just kind of, hey, we get to at least write that first row. Booyah. And we're going to modify the second row to get a 0 here. And so I will do this. So row 2, like the row 2, the new row 2 is going to be taking those row 2 values, and then I want to add. I always add, you know what I mean, but we're going to add probably the opposite, because we need to get 0. So this is the value 3. Bummer. And this is a multiple of row 1. Yes, so we have 3 plus what times 1 is equal to 0. You know what I mean? 3, negative 3. So we're going to do a negative 3 right here. So yeah, so we're basically taking row 1, multiplying by negative 3. So we'd have negative 3, negative 6, negative 9. And then I'm taking these values, 3 plus negative 3, negative 9 plus negative 6, negative 12 plus negative 9. And then to do this in your head, hell yeah, it gets a little bit crazy. But this first value goes to 0, 3 plus negative 3. Negative 9 plus a negative 6 is a negative 12, negative 15. Sorry about that. Negative, because I want to do this in my head. Negative 12 plus negative 9 is negative 21. Hell yeah. And we're going to do that. And then because we multiplied that first row by negative 3, in this slot right, because we multiplied the first row by negative 3 and changed the second row, this value right here, and got this to be 0. That's the kicker. If I turn this into a 0, then whatever I multiplied the first row by, I'm going to put the opposite of that. So I used a negative 3. I'm going to put a positive 3 here. So a positive 3. And you'll see that, hey, that's just this number right there. So, you know what I mean? The next number that I put right here is going to be negative 1, but we'll follow that same logic. Okay, so row 2, negative 1 plus, you know, a multiple of 1 is equal to 0. So negative 1 plus 1 times 1 is 0. Okay, we're going to multiply the top row by 1 and change this third row. Because we multiplied the top row by 1, I'm going to put a negative 1 here. And that's why this negative 1 shows up. But still, it doesn't seem like it did anything to the top row. But you still have to use that, you know what I mean? A lot of steps, you know, that I really can't tell you. Like, you know, I ain't proven that to you. I mean, everything has, like, you know, these steps that if you can do proofs that are mathematically sound, but even at the end of the day, I don't know if you're going to get too much aha moment from those proofs anyway. Hell yeah. Alright, so this row is going to be negative 1 plus 1. This is going to be 8 plus 2. So this becomes, well, this value becomes 0. This becomes 10. And this becomes 18 plus 3 is 21. Alright, now we want to get this row to be a 1. I'm going to divide by negative 15, divide by negative 15. This kind of looks ugly. I've been using this a lot. Just factor things out. 21 is a 3 times 7. Negative 15 is a 3 times 5. The 3's cancel. The negatives cancel. And we got 7/5 right here. Hell yeah. And this became 1. When doing matrix, if I get a little bit, you know, if I'm doing operations on the page, I'm going to circle the values that are actually being, like the new values. So those pop. So hell yeah, 1, 2, 3, 0, 1, 7/5. Now I'm going to take 10. So I have 10 plus a multiple of 1 equals 0. So this is going to be negative 10. I have to multiply this by negative 10. So this will become negative 10. And then even here, I'm going to say 10 is 2 times 5. times 7/5, the 5's cancel, and this would be 14. So I would have 14. But I can do that in my head now, where I'm just like, hey, what's this times negative 10? I'm going to forget about the negative for now. 10 is a 2 and a 5. Alright, hell yeah, my camera cut out. It makes no beeps at the 10-minute mark, so we always have to be refreshing it, because we got a little ahead of ourselves. So we, this upper row, and we multiply by 10, and I was just going to say that I can do that in my head, you know what I mean? Negative 10 times 7/5, well, 10 is a 2 times 5. Those 5's will cancel, and it's just 2 times 7. It's a negative 2 times 7. It's negative 14. Okay, so we're going to take this bottom row of 10 and add it to the top row. 10 plus negative 10 is 0. 21 plus negative 14 is, and that's where I kind of got, I was just like, that's tough for me to do. 21 plus negative 14. It's 21 minus 14, but sometimes I really struggle with that, just like I can't do that fast. So before the video cut out, I was just like, well, 14, 15, 16, 17, 18, 19, 20, 21, 7. You know what I mean? Add up and use your fingers. Like, if you're doing the mental math and you can get there with 10 digits, you know what I mean? That could save you a full hour of making a little error. And that's where my errors come up. 8, 13 minus 5 is 11. I'm just doing bizarre stuff. Things that should be 13, I will call 11, or vice versa, when it comes to subtracting. Okay, hell yeah. So now we have our upper, 117, and then we have our lower. Well, we got to get this value. What did we do to the top row? We multiplied by negative 10, and so we're going to put a 10 here. And you can see how this 10 matches that. And we could do the double check. You could multiply these things through and check to see if you have the right value. Okay, hell yeah. I'm going to rewrite this. Well, yeah, and we can do that. And I don't like this fraction, because the next thing we want is the inverse L and the inverse U. And so the determinants, that's the first thing, because the inverse equation, inverse of L is going to be 1 divided by the determinant of L times the adjoint, which is the cofactor transposed. The determinant is going to be the diagonals multiplied. But the determinant is this, going to be 117. So I'm going to have a 1/7 times the cofactor. We're just going to find the cofactor and then just know that we got to divide by 7. This one we don't have to divide by anything. And it makes me think if I did this problem wrong, because I think we should have had no, never mind. But I thought we should have had a different value here. We'll see. We'll see if we made a mistake. Well, yeah, let's double check that. I mean, let's see if we can find this value right there, which is going to be 18 should be this row times this column. And let's use our calculator, because we got food on. So negative 3 plus 10 times 7/5, and then plus 1 times 7. Now, before I actually hit the calculator, could I have done this in my head? You know what I mean? This is going to be negative 3. This is going to be 2 times 5. One of the 5's cancels. This is 2 times 7, 14. So I have negative 3, 14. There's that 11. And then 11 plus 7 is 18. All right, so we're good to go there. And now I'm just going to, well, let's double check this value. You know what I mean? Let's take this row and this column. 6, 7. Yes, so this one doesn't work. If I want to try to find that negative 9, so yeah, we made a mistake here. Yeah, that's cool. And then, because this is the place where we have our lower and the upper, and we're going to say lower times the upper is A. So this is a really cool place to double check, because I swear that we had a factor of 15. Like this was the determinant. The determinant of this lower was going to be like 15 or negative 15 actually. Okay, so hell yeah. So I'm going to have 6 plus 1 should be negative 9, and it's not. So let's go back and figure out what we did. So this lower is, again, we're just going to take the identity matrix. This 3 and this number 1, those jive. No, we should be good. But why isn't it... oh, I see. I think I see. Lower, upper should equal A. And did we do anything to this? Yes. Oh, yeah. That property. We said we were going to do that property once. You know what I mean? Where if I changed this, hell yeah, I totally apologize. Because we divided this by 1/15, which is like multiplying by 1 divided by -15. The reciprocal of this is -15. We have to change this value to a -15. So hell yeah. So, and that's cool. We're doing this real time, and some of those things, you know what I mean? You can make easy mistakes, and that would have carried through. But with these, that's the perfect opportunity to check that your lower times the upper is equal to A. And I'm glad we checked, and check just two crucial values. Sometimes the middle value, sometimes the diagonals. Hell yeah. Okay, now the determinant of this is going to be -15. Cool. All right. And so what I'm gonna do is I'm gonna rewrite this lower and this upper. But I'm gonna multiply this by 5. So it's gonna be 5, 10, 15, 5, 7, and then 35. Do you see that? Cool. So let's do this. The lower is gonna be a 1, 0, 0, 3, -15, 0, -1, 10, 1. And then this is going to be a 5, 10, 15, 0, 5, 7, 0, 0, 35. Hell yeah. So this is our lower, and now this is our upper multiplied by 5. So this is no longer A. This is 5A. Cool. So, the inverse of it is just going to be, if we do find the inverse, it's going to be the inverse of 5A, not the inverse of A. But, you know what I mean? That's the cool thing about matrices. You can multiply by a scalar and easily kind of follow it through. All right, booyah. All right, hell yeah. I turned my food down, but then this was really cool. And because, if you're doing LU factorization and you're getting your upper matrix, put your upper matrix here and then build your lower matrix over here. In the textbooks, they usually do it the opposite. You build your upper, and then on the side in the textbook, you build your lower. Just because you write left to right. But I just thought that was a cool little skill. Build your upper over here. Use Gaussian elimination to get your upper, and then build your lower over there. And the lower is just always these reverse operations. And, that's a proof that I need to go over to just not know it's hand waving to put these values here, but you're actually doing the reverse operations, and you can use a proof to get there. So yes, doing the proof would be good for me, but it's real difficult to do those proofs. All right, hell yeah. So now what we want to find is the inverse of the upper, because the inverse of A is going to be the inverse of the upper times the inverse of the lower. This is going to be 1 divided by the determinant of the upper, and then the cofactor transposed of the upper. And then this is going to be 1 divided by the determinant of the lower, and then cofactor of the lower. So this video is like, we're going to try to do 3 steps at once. The determinant was real easy. The determinant of this is -15. So we had the determinant of U is -15. And then the determinant of L was 7. We cranked this thing up by 5, so we also have a scalar multiple of 5. So there you go. So when we find the cofactor transposed of both of these and multiply them together, you know what I mean? Well, that's doing this. That's multiplying these two together. When we multiply these two matrices together, it feels like we have the inverse. I would do an inverse star because you need to divide by that scalar from the determinants. And we'll have to divide by another factor of 5. This one was kind of interesting. But what I'm going to do, I'm going to put 2 matrices here. Because now I'm going to have my upper inverse and then my lower inverse. But this isn't going to be the upper... Well, I could say this is the upper inverse as long as I put my 1 divided by -15 here. And I could say this is the lower inverse if I put my 1 divided by 7 here. As long as I kind of do that, this is the upper, this is the lower. And then I just need to know that this whole thing needs to be divided by 1/5. You know what I mean? And this will be the inverse of A. Hell yeah. And then what are we doing? We can just find the solution by taking inverse of A times B. And you're like, do we do it in this order? Hell yeah, because you couldn't do it in the other order. Try that for yourself. All right. So how do we build this? Because this, like this is the cofactor transposed. This is the cofactor transposed. Cool. Because this is going to be 1 divided by 1/15 cofactor transposed. That is the, so this matrix is the cofactor transposed. The cofactor is the minor with a sign change. Okay, so this is how and this is the upper. If I'm doing the upper, I know that at least these values are 0. You could go through and figure out why. Well, let's just pick one. Because and then the cofactor of these diagonals and these diagonals are going to be positive. Because this spot is a 1 row, 3 column. 1 and 3 add up to an even. This adds up to an even. This adds up to an odd. Row 3, column 2. That's an odd number. So, hell yeah. So the cofactor of this location is just the minor of this location. Minor says cross out row and column. Take the determinant of the remainder. That's 0. The cofactor of this location is 0. The cofactor transposed is this. So the diagonals will stay the same. Transposing this will go to there. You know what I mean? If I transpose this matrix, I would have 5, 10, negative 15. If I transposed it, I would have 5, 10, 15. And so for doing LU substitution, it's just really visual just to see that this number goes to there, this 10 would go to there, this 7 would go to there. So let's begin. I want to find the cofactor of, I want to find this location. That's going to be the cofactor of this location. There's no sign change, it's going to be the minor of that location. We're going to have 70 minus 75. Sweet. And so that's going to be 70 minus 75. That's going to be negative 5. But I'm going to try to divide by the 5 thing. So it's going to be negative 1. Hell yeah. So I'm going to do kind of 3 steps at once. Now I'm going to do the diagonal. The cofactor of this location is just the minor of that location because these are positive. So the minor of this location is doing this. And then I can divide by 5 anytime I want. So I see this as 1 times 35. That's 35. Hell yeah. That was this location, so that's just 35. So these locations, the cofactor transposed does not switch. So the cofactor, if this is the cofactor transposed, I'm sorry. If I'm trying to find the cofactor of this location, when I transpose it, it's going to be right there. Hell yeah. Oh man, camera got a little dark, so we're going to brighten it up. Alright, so now let's try to jive, because I do have food. I really turned the food down, but we really want to bust this out in the next at least 10 to 20. 10, 20. Okay, hell yeah. So I'm just going to do the diagonals. Alright, so the cofactor is the minor of this location. 1 times 35, because I'm dividing by that 5 factor. So anyway, and so that's 35 as well. So minor of this location, I see a 1 times 5, that's going to be 5. Hell yeah. Alright, so the only 2 is this. This location is going to be right here, because once I transpose it, it's going to go to that location. So I'm going to do the minor of this. I see a 2 times 35, that's 70. Oh, and it's a negative 70. That's the other thing, is that the cofactor of this location will be a negative minor. The minor is going to be 2 times, is going to be 70, so it's going to be negative 70. Same thing here. So sometimes just throw the negative in because I'm going to forget it. So I want to find the cofactor of this location, and it'll swap to there. That's the cofactor transposed. So hell yeah. And I see a 1 times 7. 7. Booyah. So we're done. We have our inverse of our upper. Let's do that inverse of the lower. If we're getting the inverse of the lower, we will have a lower matrix. These will be 0. And I can double check that by saying, hey, this is the cofactor transposed, so let's find this location. And the determinants, the minor of this location, 0. Booyah. How about this location, which would be there? The minor of that 0. This location, the minor of that 0. You know, you can see the determinant of the remainder is 0. Hell yeah. Okay, let's do this diagonal. So this one's going to be up here, and I'm going to have, and now I'm done dividing by that 1/5. So this is just going to be 30 plus 15 is 45. Hell yeah. And that was this location. Because I chose this as my cofactor, the transposed is there. Now to do the diagonals, these will not change. The minor of this location is negative 15. So we have negative 15. Bummer. And let's just bust these out. I see a 1, and then I see a negative 15. Hell yeah. These are the other two you got to make sure you get your negatives in there, because I might forget. Cofactor of that location is 3, negative 3. Cofactor of this location is going to be 10, negative 10. Hell yeah. So there's my upper, there's my lower, and now I can find my inverse. 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm still going to say that we're going to divide by negative 15 times 7, and then I'm just going to multiply these matrix together. And so, hell yeah. And I got to use a calculator for this, you know what I mean? Because we have this, this, this. So this value right there is row and then first column, you know what I mean? Hell yeah. And so this is kind of the place where the calculator comes in. So I'm going to do 35 times negative 15 plus negative 70 times negative 3 plus negative 1 times 45. So that's negative 360. And let's go down here just so we can get our first check. You know what I mean? This value is second row, first column. I'm going to ditch the first one by a 0, but the second one's going to be 35 times negative 3 plus negative 7 times 45. And we got negative 420. Because if I fill this one in, we can do a double check on reality. And so, hell yeah, this is just 5 times 45. I do this in my head. 10 times 45 is 450. Half that is 225. So 225. Sometimes I'm like, I don't even trust myself. Okay, hell yeah. So once we get this, why can we do a double check? Because we're going to say matrix A times the inverse. And you can do these in any order. You know, any matrix times its inverse. You can swap because it's always the identity. But now I'm going to take this row, 1, 2, 3, by this column, and I'm going to have negative 360. Or I should say 1 times negative 360 plus 2 times negative 420 plus 3 times 225. And what did that give me? That gave me 525. What's negative 15 times 7? Oh, damn it. So yeah, we made a little mistake. And yeah, because this isn't... Well, no. Negative 525 divided by 5. Oh, is there something where we had to... Did we not divide by 5? You know, did that thing pop up again? Because we're just off by a factor of 5. Did this lower? Did we get out of control on that? Oh, well, no. Let's see. That's interesting. I need to take a little break now. All right, I might as well film myself trying to catch my errors. And I'm glad I did that, because this is the first place I can see, like, hey, one of these doesn't work. And, you know what I mean? This is supposed to be the well, I'm sorry. If we take this matrix A times inverse A, we should get the identity. But we're saying that this is not the inverse. We would have to divide by this value. And so, you know, an identity matrix is going to be 1, 1, 1, and then zeros everywhere else. If these are big numbers, it just means that we need to divide by that number. Hell yeah, and that's kind of what we have. But we're still off by a factor of 5, and so maybe I didn't do a very good job by, I thought this matrix, because we boosted this one up. We boosted this one up by 5, but then when we took the cofactor transposed, we did so in a way where we already divided by 5 all the way through. So let's check that, though, because that's where we probably run into some errors. So this diagonal is going to be the minor of this location. Divided by 5 is just going to be 1. So that's 35. This location is 35. This location is 5. So we double check there. This location. Oh, so this one probably got messed up. No, this one was good because we have 1 times 15. or we have 70. No, yeah, this one I probably... No, this one we did right, because it was 70 minus 75, which was 5. Yeah, 70 minus 75 is negative 5, divided by 5 is 1, so we're good there. This location would have been this, and then so we're going to have a 1 times 7, and that's going to be negative 7. This location looks horrid, so that's the error right there. See how this, like, that pops out to me now? So the cofactor transposed of that location, this one I did not divide by 5. So that 5 crept back in. And so this should be a... No, this should be good because we divide by 5 there. This was 2 times 35, which was... 2 times 35 is, yeah, 70. That's all. Okay. And then the negative 70. And this is going to be our upper and our lower. And then when we multiply it together... Ah, man, that's a real bummer. I'm just off by another factor of 5. And maybe not, but yeah, this should be the inverse of A divided by those numbers, because these are the cofactor transformed. And so, yeah, this first value, first row, first column, second value, third value. And yeah, let's redo the first row, first column. 35 times negative 15 plus negative 70 times negative 15 plus negative 1. I'm sorry. Yeah. We got to go like this. So we got 35 times negative 15 plus negative 70 times negative 3 plus negative 1 times 45. I'm just going to double check the values just visually. Cool. Yeah, and that's negative 360. And now everything else checks out. And if that was inverse A, and we were multiplying by this, I would have 1 times negative 360 plus 2 times negative 4. All right, hell yeah. So I'm gonna say that we have to, find our error. And it's probably something dumb. And it's just very interesting where, yeah, it's interesting where you can develop errors. But what I'm going to try to do from here on, because that's kind of what this video is now. Like, we made an error. How do you find errors? One, I'm going to double check, this run through. A times inverse A is the first row, first column. That should be, you know what I mean? That should give me this value in the identity, where after dividing by negative 15 and 7, that should be 1. But we're just off by a factor of 5. Negative 15 times 7 is negative 105. And we are just getting 525 for that first column. And so, but we can double check it again. So we have 1 times negative 360 plus 2 times negative 420 plus 3 times 225. And then yes, divide by negative 105, and we're still getting a 5 here. Okay, hell yeah. So what I want to do, like, now this is good, because it's like, where can we do the double checks? Because we're saying that this inverse, we're saying that the inverse of the upper is going to be well, we said the upper times 5 was this. Oh, that's fast. So maybe, yeah, holy Toledo. I think that was the biggest mistake, because when I was finding the minor of this, I would have to divide by 5 both locations. Okay, hell yeah. So that was the deal. You can't just divide by 5 in one location. And so, and why did I even boost that up by 5? Oh, yeah, that was the deal. There was no reason to do that. Getting this upper right here, yeah. So what I was finding the cofactor, you know, of these locations, I can't just divide by 5. Like if I'm trying to find the cofactor of this location, I can't just say this is 2 times 7. I have to divide by 5. Like this has to be divided by 5, and this has to be divided by 5. You know, so for this was the only value that it actually worked on. So yeah, that was interesting. I can find the cofactor. So if I find the cofactor transposed of this, the cofactor transposed of this 5u, will be 5 times the cofactor. It'll just be 5 times the. I will get a cofactor transposed that's 5 times as big. But while I'm finding the cofactor transposed of this, I can't just start dividing by things. I would have to divide everything by it, and that's just why I didn't want to do this. I probably shouldn't have done that way. So let's do it twice. So we're going to try to get the inverse of the upper, and this is going to be 5 times the inverse of the upper. Basically, it's going to be the 5 times the cofactor transposed, and then still dividing by the determinant, negative 115. So that part doesn't change, but okay, let's find the cofactor transposed of this. So we're trying to find the upper. So this is, you know, basically 5 times the inverse of the upper divided by 1, negative 15. And which is going to be negative 15, 5 times the cofactor transposed. I'm just interested, right here, I'm interested in finding 5 times the cofactor transposed, which is just the cofactor transposed of this matrix. I'm getting an upper, so at least we can get the zeros right here, but we could have checked those anyway. The cofactor of this location is the minor of that location. Now, I'm sorry, to get this value, I have to take the cofactor of, because this is the transposed matrix, and this video is like, hey, can we do 2 steps at once? So the cofactor of this location is going to be 0. Hell yeah. The cofactor of this location will be the transpose of the cofactor of this location, 0. This will be the transpose of the cofactor of that location, 0. Alright, hell yeah. So we're back. And I ate some dinner, and you know what I mean, I kind of, it's so fascinating how you can catch your own mistakes, just if you have a little bit of time and space. And I don't know if you're going to be able to capture that on camera, just because on camera it's like, well, where do we go from here? We did not make a mistake, and the fact that we had to divide by another factor of 5 came up because, and we can explain this in units. My brother and I were talking about dimensional analysis. So let's talk about minors, cofactors, cofactors transpose. Like, what's the minor of a 2 by 2 matrix? Well, and let's say this is 0 and 0, but you know what I mean? We just have like a 1 and a 1 here. So the minor of it is going to be, or let's say 1 and 2, or 2 and 2. So we have a matrix that's 2, 2, 0, 0. The minor of this is going to be a 2 times 2. And so if this has dimension, you know what I mean, like in feet, what happens when we take the minor is that we double up. So the minor dimensionally is a unit, whatever the units are, squared. And so if I multiply through this matrices by a scalar, and we did 5, then when you, or I should say, when we took this upper and multiplied by 5, to take, if I take this upper matrix, upper triangular matrix, and multiply by 5, taking the cofactor of it, or the cofactor transpose, the cofactor, or just the minor, if I take the minor of every location, it would be, I would get the minor of u, but multiplied by 25, or 5 times 5. So, you know what I mean? I would have to divide everything by another factor of 5 to actually get that. And so that's where my determinant is 1, negative 15, 5. Or I can put that other factor of 5. I'm sorry, not even the determinant. Yeah. If I'm considering this to be the inverse of matrix U, and this is 5U, then, this is so, I'm kind of stumbling on, because if I multiplied U by 5, and the inverse of a matrix, so let's do this. It shouldn't be that hard, right? If I have 5U is my matrix, and I want to find the inverse of it, that's going to be, and this is what they do in this book. It's like, hey, that's 5 times the inverse of U. That should be the same. And, and then we didn't do that because we said, hey, the inverse of a matrix is the 1 divided by the determinant. Oh, that's where it pops up. We need the determinant of 5U. Cool. So that's probably where we get that other divide by 5, because the inverse of any matrix is 1 divided by the determinant of that matrix times the adjoint of that matrix, and that's going to be the matrix transposed of 5U. So sure, we found the matrix transposed of 5U. That's what this was. But the determinant of 5U is now 5 times 5 times negative 35. Alright, hell yeah. No, this is what this book is for. You know what I mean? Because it says, hey, you should be able to do these proofs. And this is why, like, I want to be able to just multiply this by 5 to get rid of, but then I want to figure out what I'm missing all the way through. And so, yeah, let's slow down on this. We had matrix U, and then we took matrix U. So if I had matrix U, then if I wanted to find the inverse of U, this would be 1 divided by the determinant of U times the adjoint of U, which is 1 divided by the determinant of U times the cofactor transposed of U. I chose to multiply U by 5, which, you know what I mean, is just this. And if I took the inverse of this, well, that's 5 times U. And if I took the inverse of that, that's 5 inverse U, because the scalar can come out, due to matrix properties. Oh, no, and I didn't want to do that anyway. I wanted to have 5U and take the inverse of this, which is going to be 1 divided by the determinant of 5U, matrix transposed of 5U. Cool. So this is the new matrix 5U. Well, and then what are we saying? Cool, we did that. I wanted to multiply by that 5, but how is this related to inverse of U? Because if I do get this matrix, the inverse of 5U, how is this related to just the inverse of U? Well, I would say the inverse of U is equal to 5U, the inverse of 5U divided by 5. So that we have to keep track of that. And here, so we have to divide by a 5 here, and then here we pick up another divide by 5. So those are the two places that were, because we chose to do this, 5 times the matrix, 5 times U, just to make our math simple, we popped up, we have to divide by 5 downstairs in 2 locations. And those are the locations. So let's just write this all in one go, because this is this. As you can see, that's this part, and then divide by 5. So I'm going to say the inverse of U is going to be 1 divided by 5 determinant of 5U times the cofactor transposed of 5U. Cool. We found the cofactor transposed of 5U, And now we need to Alright, I need a little bit more space now, because what we have here is what I was just considering inverse u divided by a scalar. That's how I was considering this. Inverse u divided by some scalar. I'm going to say this is inverse u star. That's what we have here. We have inverse u star. You know, I'm pretending like it's inverse u, but it needs to be divided by a scalar to actually make this inverse u. And that's the same thing, you know what I mean, over here as well. I would have to divide by 7 to make this inverse of the lower. And I just need to know like what these scalars are. So I'm going to say that inverse A is inverse u. And then that's going to be inverse L. Oh, bummer. Inverse U, inverse L. How I have it written is 1 divided by the determinant. And sometimes, instead of writing out the equation, sometimes I just like to write in the numbers. So, you know, I'm considering this 1 divided by the determinant of U. Because at the beginning of this problem, we solved for the right L and U. This is the right L, this is the right U. It's just when you take the inverse, you have to divide by the determinant, and that's a scalar outside the matrix, and so that is my biggest kind of hang-up with this. But this is L, this is U. The determinant of U is 7. The diagonals multiplied is 7. The determinant of L is negative 15. So when I write this, I'm going to be negative 15, and this is going to be cofactor transposed of U, and this is going to be negative 7 cofactor transposed of L. And then let's throw, and now I can write it. I can be like, hey, this is the determinant of U, cofactor transposed U, 1 divided by the determinant of L, cofactor transposed L. This is inverse A. What I chose to do was multiply the U by 5. So let's write this. It shouldn't be too hard. You know, how hard could it be? I chose to do this. 5U inverse. Divide by 5. L inverse. And I'm really satisfied with this because I knew to do it, but then I didn't realize I needed to divide by 5 again. I could have got there, but instead of just being like, hand wavy, I need to divide by 5 again, like this is, and I would consider this even just like a half proof, because that's what I'd never know what a proof is, because, I mean, the fact that I'm actually saying cofactor transformed, cofactor, and then using minors and stuff, well, I would have to prove what the hell those are and how they're related to matrices, and, you know what I mean, know that I can multiply them, or something, you know what I mean, that's where the proofs are, you know, stack one upon the other, and, yeah, I still don't get too much aha moments. If I can follow them, that's the aha moment that I get. Hell yeah. Alright, so let's, this shouldn't be too hard. So we have, this is going to be 1 divided by, well, yeah, so we have 1 divided, it's just this. So 1 divided by the determinant of 5u, and then cofactor transposed of 5u. How much? Yeah. Cofactor transposed of 5u. Alright, so that right there is inverse u. And then this is going to be 1 divided by the determinant of L, cofactor transposed as L. That's going to be normal, but this was the one that we decided to mess with. Yeah, so this cofactor of 5u definitely shows up. And let's compare the cofactor. So, let's compare the determinant of 5u compared to the determinant of u. I'm proposing that the determinant of 5u is just 5 times the determinant of u. And so for our problem, let's see if that's the case. The determinant of 5u is 5, so an extra 5, and then 5 times 35. 5 times 35. Oh, see, yeah, I'm probably messing up again. Yeah, so the determinant of 5u is 5 times 5 times 35. That's going to be 875. Oh, and I'm probably wrong on this. Anyway, the determinant of, yeah, because, oh, the reason is because we said we picked up a 5 times 5 here. We picked up an extra 5 times 5 in the numerator. And in the denominator, we should have picked an extra 5 times 5 up into the denominator. Unless there's more that we picked up as well. So the determinant of u, that was, drop my pen. That was going to be, determinant of u is only 7, is that, am I doing the wrong one? Yeah, the determinant of u is 7, and then I multiplied it by 5. Alright. So the determinant of u is 7. The determinant of 5u is 8. Ah, bummer. Yeah, it's 875. So 7. So yeah, 875 divided by 7. Divided by 5, divided by 5, divided by... So yeah, it's a factor of 3. Yeah, so what are we... Yeah, I forget even like what we're comparing. This part is what we messed with. And this part should have just been 1 divided by the determinant of u, cofactor transposed of u. Cofactor transposed of 5u made this, 5 times 5 upstairs. The determinant of u made that 5 times 5 times 5 difference downstairs. And then I'm saying that we're dividing by another 5. Or am I getting that wrong? Or am I saying after all of that, if what should it be? If I have 2 5s upstairs, like two 5s upstairs, and then 3 5s downstairs, we should just be good to go now. This is what we should have: 1 divided by the determinant of u, and then cofactor transposed of u. We have this, but this is 5. Ours is 5 times 5 times 5 more downstairs, and 5 times 5 more upstairs. So I actually need to multiply the top by 5. Huh. Now, is that true? 5 inverse 5u. Or u, inverse u, is 5 times u inverse is equal to 5 times the determinant of 5u cofactor transposed of 5u. I shouldn't have messed with this at all, because even if I get the numbers to be right, I'm kind of at a loss of like where. I'm just using kind of dimensional analysis to be like, hey, those should be the same, or how do I compare inverse u to yeah, I want to, so this is k. So what scalar, 5u inverse, what scalar makes these two equal? And I think that scalar k is 5. And it would be a multiplication of 5. I think that's what I'm getting there. So let's now try it. Alright, and from this problem, we were saying that this value has to be negative 130 divided by 5, but that's it. It just has to be negative 72, negative 420 divided by 5. This has to be negative 84, 220 divided by 5, and this has to be 45. So let's check that before we move on with my little sheet of paper. Alright, I must have dropped my little sheet of paper, but here's going to be A, matrix A, and so we're going to take the first row. Alright, hell yeah. So I'm going to take, so we got A times inverse A. I just have that first row of values, and this is where circling them probably helps. And shouldn't this be negative 72? Yeah. So let's see what we got. 1 times negative 72. Plus 2 times negative 84 plus 3 times 45. And we're good. A times this, because this was supposed to be yeah, this was 1 divided by, those. Oh, and I have this wrong too then. Negative 5 times 7. This has to be negative. Oh, no. I mean, here's my two determinants. The determinant of U is this. Determinant of L is that. And so this, when I multiply A and this is inverse A star. I get the identity matrix, but multiplied, by negative 15 times 7. I have to divide by negative 15 and divide by 7 to actually get that identity matrix. And so inverse A is actually this value divided by 105, but negative 72 divided by negative 105 is just not a nice fraction, 24/35, and that's what we try to avoid is those fractions. Okay, so at least those values are correct. And now we can go back to maybe what I was trying to do. And so, yeah, because we have, this is the inverse transposed of 5u. Like, we actually solved for that. So we definitely have that. And when we took this inverse transposed of 5u, we needed to divide this by a factor of 5. We were too high on this one. But if I'm saying that I'm actually going to use the determinant of 5u, like this, 5 times 5 times 35, then we're 5 times 5 times 5 too high. Because this should be 117. So that's what's happening there. And the determinant from a dimensional analysis perspective is if it's a 3 by 3, that the units on that determinant are a multiple, are the units to the cube. They're units cubed. And so that's where, yes, if I'm treating this as determinant of 5u, I'm picking up 3 5s downstairs, and that's really dominating. I'm only picking 2 5s upstairs. And this whole thing has to be dimensionally balanced where, the 5s cancel, and so I wouldn't have to multiply everything by 5. What we did must have been just a little sidestep of like dipping our toes into, multiply this by 5, taking the cofactor transposed, and then only dividing by 1/5. Oh, wait. Hell yeah. But I would have had to divide this by another 5. If I actually wanted to get this to be inverse u, I got to divide this by another 5. Cool. So dumb. And I think I'm just going to move on. And we're just going to say, hey, this isn't the inverse of u. It's not the inverse of u anyway. It's the inverse u star. You have to say, if this is the inverse of u, you have to divide it by the determinant of u. So this is the determinant of u, negative 50. We got to take this matrix and divide. That is the inverse u, but we're scaled up on this by a factor of 5 too much. So, but it helps. It's still whole numbers, and so I can still do the matrix multiplication. But when I get those values, I got to divide by a factor of 5 for sure. Okay, let's get this value. First row, second column, 0, negative 70, 10. So that's going to be negative 60. This value, second row, second column, 0, 35, 70. Oh, so that's 70 plus 35 is 105. This one I know from just doing it, so it's going to be similar. It's going to be positive. How do you do 7 times 150? I don't know. Actually, I don't know. Oh, yeah, I remember this one. Yeah, so it's like 7. Don't do 7 times 15, double this. 7 times 30. And you can be like, that's 210. Or you can be like, 7 times 3 is 21. Add a 0 is 210. Half of 210 is easy. That's 105. It's going to be positive. Positive 105. Hell yeah. Okay, so let's do this value. Third row, second column. Negative 50. And then this is going to be 5 times 15. Same thing. I don't know. You know what I mean? What are you going to do? Do 10. 10 times 15, 150. Divided by 2 is 75. Negative. Negative 75. And this is negative. Let's circle all these. Okay, last value. First row, third column, 15. All right, let's check one of these. How about check this third column against, so if this is inverse A, kind of, still got to divide by the determinant, but the determinant is negative 15 times 7, so if this value right here, if I take A times the inverse A, I should get the identity of 1. I'm going to get negative 105 because dividing by negative 105 is 1. But when I do these three things, I should get negative 105. Let's do it. And let's, is this 15, positive 15? So we got 15 plus 2 times 105 plus 3 times negative 75. I was trying to shoot for, so I messed up. Yeah. What we just did was first row, third column. That would have been that value, which is 0. We're trying to find, when you multiply two matrices, that's why I'm always pointing to this location of the second matrix, and that's probably a bad habit. I'm saying this matrix multiplied by this matrix, but I'll point to this location, which, doing so, I'm saying 1, 2, 3, 1, 2, 3, 1, 2, 3. If I say I'm pointing to like this location right there, and I'm meaning that location. So to get this value after the multiplication, it's third row, third column. So cool. So I'm still pointing right there, and I should be pointing at, you know. Anyway, so hell yeah, third row, third column. So we have negative 1 times 15 plus 8 times negative, or 105. Oh, bummer. Plus 18 times negative 75. All right, so we got negative 525. Is this one where we said we're a factor of 5 too high? I thought we divided everything by 5. Oh, bummer. What the hell? Oh, yeah, no duh. Yeah, because we got these values, and then when we did our matrix multiplication, yeah, we got to divide these by 5. Oh, this is getting messy. I apologize. So we got negative 12. 105, this is 21. I have to maybe just give up on this because I don't know what I'm off by no more. 321. Negative 75 divided negative 15. But yeah, I mean, I was doing that, right? I was saying that this was negative 75, and no, we had to divide everything by 5. So now we should be good to go. So this location should be third row, third column. So it's going to be negative 1 times 3 plus 8 times 21 plus 18 times negative 15. And then, yes, we're good on that. Let's check this middle value. So we got 3 times negative 12 plus negative 9 times 21 plus negative 12 times negative 10. And yes, that is the identity. We can check the other values. Yeah, why did that turn out to be 0? I mean that was kind of bizarre. So let's check that one again. So we have 1 times 3. Oh yeah, because it's just a multiple. 0 times 0, 0 times 3, 0. You know what I mean? It is still 0. But we have 1 times 3 plus 2 times 21 plus 3 times negative 15. Hell yeah. Okay, booyah. And, we still got to get the answer to this problem. But we did find our inverse matrix. Inverse A is going to be 1 divided by negative 15 times 7 times this matrix, which is negative 72, negative 12, 3, negative 84, 21, 21, 45, negative 10. That's positive 45, negative 10, negative 15. All right, so this is inverse A. We have AX is equal to B. So our vector of unknowns is going to be inverse A times B, which is this matrix and the scalar. This all is inverse A. But multiplied by B, negative 5, 9, negative 4, is going to be our solution of vectors. Vector of solutions. And I wasn't a big fan of actually getting verbiage right. You know what I mean? And maybe I was just a fan of I'm a fan of fundamental understanding, which usually doesn't involve numbers, but matrix algebra kind of does. Like the fundamentals are the numbers. It's like if we just lived in math world and there was nothing physical, you could still do everything you wanted to do with the numbers. And that's what drives me crazy, because the fundamentals are the numbers, and the proofs are the numbers, where physics in the real world is like you can just do the experiment, and there's a lot of variables at play, but the fundamentals kind of simplify that. Anyway, that's what I'm thinking. All right. Oh yeah, so let's do this. And again, this is calculator city, because we got to do that. I can't do this in my head. Well, maybe we could. 72 times 5, that's 72 times 10. And I just forget about the negatives and then bring them back in. And this is going to be 720, half of it. Well, half of 700 is 350, half of 10. So this is going to be 360. Cool. And then maybe I can just, because I said I can't do it and I need my calculator, but now I can actually 5 times 72, maybe I'll ring a bell that, no duh, Shaun White doing 720s. If it goes halfway, it's 360. Hell yeah. All right. So this is going to be 360, but we got to add it to, what's this? Well, 10 times 9 is 90, and then 18, 108, and that's going to be negative. So 360 minus 108 minus 12. Minus 108 minus 12 is minus 120. 360 minus 100 is 260. Minus 20 is 240. Oof, brutal. And so we have 1 divided by negative 15 times 7, and then we got 240. I would have to, And then do it with your calculator. Negative 72 times negative 5 plus negative 12 times 9 plus 3 times negative 4. And yeah, 240. Well, let's do the next one. We got this. Think 840 divided by 2, that's 420. And this is going to be negative. And then we got negative, positive, negative. So there's another negative. So we got negative 420. Hell yeah. And then we have, and then this, 4 times 2, 4 times 1. This is going to be 84. So we have 420. And let's not think about the negatives. Every time I say negative, my mind goes blank. So 420 and 84. 420, 20 plus 80 is 100. So 500, 504. And now we're going to, and then that's going to be that negative value. And it wasn't even. No. Yeah, I apologize. So this is a positive value. This is a positive value. This is the negative value. See, my bad. So we got to go 240 plus this. How do you want to do this one? You want to do 2 times 9 and then plus the 0 is 180 plus another 1. So it's going to be 189. And we're going to add that to 420. So 180. So I'm hearing 100 and then 420. 420 goes to 520. So I got 520. Now I'm hearing 80. That goes to 609. 609. Yep, 609. Trying to do this in my head. But then we're going to subtract. So 609. How am I going to remember that? Well, that's pretty easy now. But 609. All right, booyah. And then we're going to subtract, 84. So 609, 609 subtract 4 is going to be 605. And then subtract, if we have 600, subtract 80 is 520, 525. Holy hell. I think that's the favorite part of my videos is actually trying to do stuff like that. Negative 84 times negative 10 plus 21 times 9 plus 21 times negative 4. And we got 525. Brutal. Okay, so double this. This is the negative, this is the negative, this is the positive. So these two add. So we're going to say this is 225. Do you see that? Times 10, 450 divided by 2, 225. Hell yeah, we're going to add it to 90. And that's going to be a negative. I'm just going to say, forget about the negatives. But those two add, and then we're going to subtract. So we're going to add these. And then the answer in the end is going to, well, it doesn't have, we'll see if it's positive or negative. But, so we got 225 plus 90. So I'm hearing 220. And then 220 plus 80 is 300. And so we're going to have 310. And then do we have a 5 somewhere? Yeah. So 310, 5. 315. Oh, I like that. Because the 11s and 12s suck. If you say 310, 5, 310, 4, 310, 2. I think 310, 1. I was trying to figure out what else would you call it. Would you call it 311? No, but 310, 1. 310-1 is 11. 310-2, and I think that's going to help me do mental math way better. Yeah, so let's run through that again. 225. Ugh. And then we have to add 90. 220 at 80 is 300. Add another 10 is 310. And then 310-5. Hell yeah, so I like the ring to that. 315. 310-5. 315. All right, and then we're going to subtract 40. So, yeah, see, this is brutal. 315 subtract 10 is 305. And then we got to subtract, let's just say it's 300. Subtract 30 is 370. So we got 375. And it's negative 375. Holy hell. So we got 45 times 240 plus negative 10 times 525. I'm not even doing the right things. So it's this row in this column. 45 times negative 5 plus negative 10 times 9 plus negative 15 times negative 4. But this is cool because you should always guess, and then for sure guess the negatives, guess positive, negative, try to get the close answer. And then even if I made a mistake, it couldn't be that bad. Oh, we made a mistake. And it was pretty bad. All right, well, let's see if I plugged in the numbers wrong. No, I didn't. Okay, so this is going to be 225. Yeah, 225 plus 90. Let's just say it was 200 plus 90, that's 290. Plus 10 is 300, so that's 315. And that's a negative 315. Oh, yeah, duh. So if I have negative 315 and I'm going to subtract... oh, and look, I probably said something bizarre. But I got to subtract this, which is 4 times... So. Alright, hell yeah, a new battery, some new juice. But hell yeah, I got 315, and then I got to subtract... I'm going to have a negative, but I got 315, and I got to subtract this, which is 2 times 30. This is 60. You know, so I got to subtract 60. So I got 315. Subtract 15 is 300. Subtract 45. Subtract 40 is 260. Subtract another 5 is 255. So I have negative 255. All right, booyah. All right, hell yeah. And sweet. Negative 255. Yeah, that's what we had from that. Okay, so that, and then if we divide these, so we go 240 divided by negative 15 divided by 7. Oh, no. So I did make an error on this one. Ah, shoot. Okay, so we have an error, and if this is our A inverse, if we multiplied these, I thought we already did that. You know what I mean? So let's do the double check on this, and we'll double check all 9 of these values. A times inverse A should be the identity. So we have 1 times negative 72 plus 2 times negative 12. And I'm doing the wrong ones, so and maybe that's where I was running into errors last time. 1 times negative 72 plus 2 times negative 84 plus 3 times 45. Okay, so that checks out. We're going to do all the diagonals. That one would be second row, second column. 3 times negative 12 plus negative 9 times 21 plus negative 12 times negative 10. That checks. This diagonal. And maybe we just did our numbers, I don't know. I mean, should we now let's get this diagonal done. And so we have negative 1 times 3 plus 8 times 21 plus 18 times negative 15. So that checks out. Diagonals check out. So maybe we did kind of mess up. I'm going to do negative 15 times 7 inverse stored as x. So 240x is that. But maybe we are okay. I mean, the way to check these answers is to do 1 times 240x, which is this, plus 2 times 525x, which is that, plus 3 times negative 255x. Oh, whoa. No, that should work out, yeah. And that's negative 5. Yeah, so these are this is our answer. Maybe I just haven't done this problem, you know what I mean? And so we have 3 times 240x plus negative 9 times 525x plus negative 12 times negative 255x. And that's 9. See, that's where I hate second guessing myself that we have the wrong answer just because it's not like a 1, 2, 3 answer. You know what I mean? And so, alright, so we have 1 times 240, negative 1 times 240x plus 8 times 525x plus 18 times negative 255x. See, that's the one that's wrong. So maybe, negative 1 times 240x plus 8 times 525x plus 18. And so, so one of these values is wrong. And we'll see if it's probably that. Well, this value worked out for the other ones, so this value is not wrong. It's got to be one of these rows, because this row, I didn't use this row to do those other values. So something in this row is wrong. And so, but this diagonal was right. So let's try to find this matrix times this matrix. So let's, yeah, I'm bummed that that's not working. Let's do this again. 45 times negative 5 plus negative 10 times 9 plus negative 15 times negative 4. That's negative 255. Alright, so this matrix times this matrix in this location should be 0. So we have third row, second column. So we're going to do 12 plus 8 times 21 plus negative 180. That's 0. How about that one? This row, this column, so we got 72 plus 8 times negative 84 plus 18 times 45. See, that one's wrong. So this is this a negative? You know what I mean? Is it negative 45? Nope. So something in this row is wrong. It's probably just that value. So where did we get that value? We got that value from multiplying these two matrices, which is third row, first column. And so we would have, oh, it's 5 times 45. Well, 5 times 45, but then I thought we divided by 5. How about these other ones? So second row, this is going to be 35 plus 70. That's going to be 105. Holy hell. So this whole row is off. So this should be 105 divided by 5 is 21. So this should be 21. Is that right? No. I'm messing up. Sorry about that. Second row, first column. So we should have negative 3 times 35 plus negative 7 times 45. Negative 420 divided by 5. So that should be negative 84. How about this one again? Third row, first column, 5 times 45. Check this lower, inverse lower times in of upper. You know, so this times this should be 0. So 45 times 1 plus negative 10 times 3 plus negative 15 times negative 1. Yeah, so that's... so that value's off. Alright, I'm going to take a little break. Alright, hell yeah. So we're back. And I don't even know where we're at. Oh yeah, are we still trying to find our error? Oh, damn it. I do not want to do this. Oh, that's interesting. Yep. Oh, and, I mean, yeah, we just know that this divided by 5 is the inverse of the upper. And so we should check just to make sure the upper and this are legit. So the upper is 1, 2, 3, 0, 1, 7 fifths, 0, 0, 7. Cool. So these two added up should equal, oh, the inverse matrix, yeah. Because this is the inverse of the upper. It should be 5, 5, 5, 0 everywhere else. So first row, first column. Huh. Yeah, I think I might just call this video because we got overwhelmed. You know what I mean? And so that happens where it's just I would just want to start over. You know what I mean? We learned, I think I learned some things, but man. Alright, we're going to be done with this. Thanks for joining me. That's the video. Alright, hell yeah. So we have linear algebra. We're going to try to do a speed run of lower upper factorization. We have a 3 by 3. What I'm going to do is I'm going to put two matrices. I'm going to do 3 dots for both of them and kind of separate them. This is kind of my multiplication line. And then another 3 by 3. It's called lower upper. So A we can transfer into a lower and upper. So I'm going to say this is my lower. We build the lower based on what we do to the upper. The upper is simple Gaussian elimination. First row is 1. If it wasn't 1, we'd have to do something, and I'll share what that is in a second. But now we just get this row to be 0. So I'm going to say 3 plus, I got to multiply the first row by negative 3. Okay, so 3 plus negative 3 is 0. I need to write out the first row too. Or this is like at least I can do one step. I can at least start with the Gaussian elimination from here. So it's 3 plus negative 3. Negative 9 plus negative 3 times 2 is negative 6. So negative 9 minus 6, negative 15. Negative 12 minus 9, negative 21. Because I multiplied the first row by negative 3, I put a 3 here, which is just that value. This value will be negative 1, but we'll get to it in a sec. So I need to get this to be 0. Negative 1 plus 1 is 0. Sweet. Multiplied the top by 1, so this becomes negative 1. Because I said so. Alright, or just because it says so. You know what I mean? So 8 plus 2 is 10. 18 plus 3 is 21. Okay, hell yeah. I need this to be a 1. I'm going to divide by negative 15. Negative 15. Now this is a 1. Because I divided by negative 15, I'm going to multiply this by the reciprocal. This was a multiplication of 1 divided by negative 15. I'm going to do the opposite, which is multiplying by negative 15. Hell yeah. This is 3 times 7, negative 3 times 7. This is negative 3 times 5. The negatives cancel as 3. This is 7/5. Alright, to get this to be 0, I got to multiply this by negative 10. And then this becomes 0. Multiply this by negative 10. It's the same thing as negative 5 times 2 times 7 divided by 5. 5's cancel, we got negative 14. 21 plus minus 14 is 15, 16, 17, 18, 19, 20. 21 is 7. Hell yeah. Alright, so there is my upper. With those being circled, there's my upper. I multiplied by a negative 10, so I do put a positive 10, and you can see those values are the same. Okay, and so here is my lower. If I multiply these together, I do get my matrix. Hopefully I didn't make any mistakes. Now what I want to do is find the inverse of the upper. That's going to be the transpose. It's going to be 1 divided by the determinant. Determinant's 1/7, times the transpose of this. So I have a 1/7. The transpose of this is the cofactor transpose is the cofactor of this, and it's going to be an upper. The inverse of the upper is going to be an upper matrix, so these are zeros, but we can check that because I'm going to do this, and this is the cofactor of that location is 0. So the transpose is 0. How about this location? Cofactor is 0. This location, cofactor is 0. Alright, let's do this diagonal. This is going to be the cofactor of this location. So I have 14/5. I'm going to actually write that out. Minus 3. So that's going to be minus 15/5. That's negative 1/5. Hell yeah. That's going to be this location. On the transposed is this location. The diagonals do not transpose, so the cofactor of this. And then I've been doing the minor, but I did all the positive ones. The minor of this, this, and this are all positive. So the cofactors are the same as the minors. Alright, so the minor of that location is 7. This location is 7. This location is 1. So we got 7, 7, 1. I need this location, which is the cofactor of that. The cofactor of this location is a negative. So I'm just going to, and these are both going to be negative. The minor of this location is 7/5. So we got negative 7/5. And then, and that was this location. This is going to be the cofactor. The minor of this location is 14. So it's going to be negative 14. Hell yeah. And this is going to be 7/5. So hopefully I did that right. Inverse lower is going to be 1 divided by the determinant. So that's 1 divided by negative 15. Times, so that's going to be 1 divided by negative 15 times the cofactor transposed of this. So I'm just going to do three more rows. Hell yeah. It's going to be a lower, so if you trust me, do these, but we'll double check. This location, and because these are zeros. The minor is 0. How about this location? The minor is 0. This location, the minor is 0. And then the transposed of those are up there. The transpose, that's the transpose, that's the transpose. It's just doing that. The diagonals do not... Let's do this value. So I'm going to go, how about that one? That's going to be 30 minus 15. So that's going to be 15. And that's going to be right there. The diagonals don't transpose. So we have negative 15. I can do all three. 1 and then negative 15. These do transpose. I mean, the cofactors of these locations are the cofactors of these locations, which is the negative of the minor of that location. So that's going to be 10. It's going to be negative 10. The minor of this location is going to be 3. That's negative 3. So we have negative 3, negative 10. So we have our upper, our lower. Multiplying these together is our inverse. Inverse is inverse upper, inverse lower. It's not lower, inverse lower times inverse upper. There's a proof on this. I'm speed running, so I'm not going to go over that. Hell yeah. Matrix multiplication is row and column. So we have negative 75. That's not negative 75. Calculator time. 7 times negative 15 plus 14 times 3 plus negative 1. That's negative 64. Hopefully I did this right, but who knows. Well, let's get one row going. So this is going to be second. So we got negative 21 minus 7. Negative 28. This one is going to be, is that 5? Is that 5 down there? Can't tell. Positive 5. And then so if this is A and this is inverse A, but I mean I still have to multiply it by these scalars, which is these scalars add up to negative 105. I should get the identity by a factor of 105. So negative, so I'm going to do 1 times negative 64 plus 2 times negative 23, negative 28, plus 3 times 5. Hell yeah. So yeah, we're money. So we're looking good. Let's get this one. First row, second column. Negative 140. Plus 2, 10/5. Oh, yeah. So that I'm glad I'm using the calculator, else I would be messing this up. Negative, yeah, because that's negative 140 plus 2 is negative 38. Cool. Next location. Second row, this column. So we got 7, and yeah, this is going to be positive 14. 7 and 14, 7 plus 14 is 21. I'm going to double check that because 7 plus negative 7/5 times negative 10. Yep, hell yep. Okay, and that value is just negative 10. Cool. And we can even do a double check. This times this has to be 0, so we got negative 138 plus 2 times 21 plus negative 10 times 3. Oh, it's not. Okay, this row and this column. So do we have a mistake? Negative 138, 2 times 21, 3 times negative 10. Yep, bummer. I thought we could do this without making any mistakes, but so now I'm going to check if this is the lower. Lower times inverse lower should add to the identity by a factor of 15. And so, you know what I mean? So this, you know what I mean? This value should be negative 15. This one would be negative 15, negative 15. All the others should be 0. So if I wanted this value, we would have 0. This one would be 0. This one would be 0. Cool. This one would be 0. So, yep, those are opposite. This one should be 0. So 15. And then, so, oh, yeah. No. Let's see. This is negative 15, negative 30. Yeah, we're off right here. So, because we have 30, no, we have 15 plus 5, and this is minus 3. Yeah, so we're off right here. All right, so even in speedrunning, we caught a mistake. And so, cool. So, yeah, so this... Yeah, because if I was trying to find this value, it would be third row, first column. It would be 15. Minus 30 is 15. Oh, yeah, see, this is... I didn't know what the hell that was. This was 15. It wasn't positive 5. All right. Whew, brutal. But that's cool. We actually found that pretty fast, and we actually found a way to do it. But anyway, let's get on with life. And so what did that mess up? Every time I used this first column... the value, yeah. So, I think all of these are bad. So we're going to do calculator crush time. 7 times negative 15 plus negative 14 times negative 3 plus negative 1 divided by 5 times 15. And so we got negative 66. Second one is going to be negative 21 minus, can I do this? This would be 3, so minus 21. That's negative 42. And then the third one is 15. Now, does this work? Because I don't even trust myself on that. Minus 84 plus 45. Hell yeah. So that works. I'm going to say we're good to go there. There's just a lot of math to do, so you can mess up. So these values. This value right here, first row, second column. 0. 140. This becomes 2. Negative 100. So it's, yeah, negative 138. Similar values. This one, second row, 7. And this becomes positive 14. Positive 14. So 7 and 14 is 21, negative 10. So yeah, we were really close. We just had this to be 15, negative 42, negative 66. But yeah. Okay, last one. First row, third column. Hey, this is going to be negatives make positive. This is 3. All right. Getting there. This is positive 3, 7, 21. Last one, it's going to be negative 15. Okay, hell yeah. And I think we're just good. So now what we can do is say that we have our inverse of A. I'm going to grab a new sheet of paper. Alright, hell yeah. So I took that inverse of A that we got, and I put it right here. But we do have to, the inverse of A still has to have these scalars. You know, to actually make it the inverse of A, we got to divide by those determinants. And so, heck yeah, so this whole thing is the inverse of A. And so we have inverse A times B. I should do that. And what is this? This is the solution matrix, because we have AX is equal to B. We're going to multiply by the inverse A on both sides. This becomes the identity. It goes away, therefore. And we have, and when we multiply these two things, we get our solution vector. So that's what we're going to do. Hell yeah. So it's just row and column, but then we got to divide by this. So we're going to divide by negative 105. But yeah, we can do this. So we got negative 66 times negative 5 plus negative 138 times 9 plus 3 times negative 4. And so we get negative 924. And maybe, I don't know if we messed up. You know what I mean? We could check this one more time and just do like this one and this one. This should give us 105. So we're going to do 3 times negative 138 plus negative 9 times 21 plus negative 12 times negative 10. Oh yeah, and that doesn't. So yeah, we have another massive error. Because if this is A and this is inverse A, it should give us the identity, off by a factor of negative 105. We just did this diagonal, and we did not get what we wanted to get. So yeah, this is interesting. Trying to do a speed run. But yeah, so we have to check. Yep, so that's kind of what we thought we had. And this is what we're trying to compare it to. Yeah, now negative 138 times 1 plus 21 times 2 plus negative 10 times 3. No, that's not right either. Because that's that row and that column. Negative 38 plus 21. Okay, so yeah. All right, so if this, we got some mistakes. All right, so if this is our lower, and we should just make sure our lower and upper add up to A. And so we have first row, first column, 1, 2, 3. And then second row, first column, we have 3. This is 9 minus 15, which is negative, I'm sorry, 6, positive 6 minus 15 is negative 9. And then we have 9, and this is going to be negative 21. So 9 minus 21 I guess is 12. 9 minus 21 is negative 12. Cool. And then, yeah, so these should be good. But we'll keep on keeping on. Negative 1, negative 2, this is 8. And then we have, this is going to be 14, 7, 21, minus 3 is 18. All right, so our lower and our upper are good to go. And, I mean, these are checks that we should just always do. So when we multiply the lower and the inverse of the lower, you know what I mean, we should get the identity matrix. We're going to be off by a negative 15. So that's why, you know what I mean, like this value is first row. So this is negative 15. The diagonal is negative 15. This is negative 15. So now we're going to check, let's check the opposites. Or I mean just the corners. So we're going to do, okay, so this value would be this row and then this column. Yeah, so we're off by, oh no, that should be, these should be 0 though. It doesn't matter what the scalar is. Yeah, so that's where we're running into problems. Is 1 times, yeah, this row and this column should be that value, and it should be 0. So 0, 0, no, we got 0, 0, 0. Sorry, my bad. That's one of my things that I always do. When you're doing these, you should always look for zeros. Look for zeros first. Hell yeah, the zeros cancel. Look for negatives. And but the zeros dominate on this. How about, and then this one would be right here. So we have 15. 15 is 30 minus 30, so that's 0. Let's do this one. Second row, first column. Negative 45. 45. 0. So that's 0. How about this one? 0, 10, negative 10. Alright, so now here's the only other two to do. First row, second column, 0, 0, 0. And then this one, and maybe I already did, no, I haven't done these. But yeah, so 0, 0, 0. Okay, so this one is legit. Now we're going to check the upper. These two matrix multiplied together should be the identity, off by a factor of 7. So check the diagonals. So row and column. I'm going to have 7, and that's it. And then I'm going to do this one, 0, 7, 0. And then this one, 0, 0, 7. Okay, I'm just gonna do this. So this diagonal. So we have 21. Ooh, this one looks off. Yeah, that value is probably off. Well, let's check it out. Maybe not. We have 21. And then this is going to be negative 7/5. Yeah, this value is off. Okay. So yeah, that value is probably off by a factor of 5 or something. But let's check it then. I mean, if I'm assuming that this is, I need to find the matrix transposed of that location. And then, I mean, alright, hell yeah, I let my camera cool and we're back. I kind of forget where the heck we even were, but we were. Alright, hell yeah, that battery died. Okay, so what we're doing is we're double checking. The lower and upper are good. It's probably the transpose. We were thinking this value was suspect, so we need to find the cofactor. That's kind of where we left off. The cofactor is the minor at this location with a sign change. The minor at this location is 17. I mean, 2 times 7 is 14, so we do have a negative 4 there. So we're good to go. Okay, so let's move down because we were saying that this times this is the identity. And so, what were we? Maybe this first row, second column is 7, or is 14. So that checks out. That's 0. Which one? And maybe we're just fine. And actually, because sometimes I forget to do this. You know, so if I'm trying to find, you know, this value. After multiplying, it's going to be 0, so it's going to be this row, first column, and that's 0. Yeah, so we're good. This value is first row, third column. This is going to be 21. Oh no, this is the one that was suspect. That value up there, first row, 21, negative 7/5. Now this should work out because we got negative 7/5 and then minus a bunch of fifths. Yep. So we got negative 14 fifths minus 7 is negative 21. Well, let's do this one again. So we have 7 times 3 plus negative 14 times 7 divided by 5 plus negative 1 divided by 5 times 7. And that's 0. Okay, yeah, so this one's good. And I think this one was good. And we're saying that these two, so it's probably just multiplying these together or something. You know what I mean? So let's just we got 9 things to double check. That's just the bummer of this. It takes some time to double check errors. Alright, that's good. And it was this row that was, it was this second column that was totally suspect. Yeah, it was multiplying this times this. That was bad. So this value could be wrong. So all 3 of these values could be wrong. So we have negative 14, and it was probably using this thing. So negative 14 plus negative 1/5 times negative 10. Yeah, this is negative 12. So my bad. I probably didn't divide by I probably did like, yeah. So this value right there is negative 12. And that was our error. And honestly, do you think I could have, like, what value, look at this, the only one that's way off, but this was 66, so I wasn't questioning anything. So now we should be good to go. This times this should be second row, second column, should be negative 105. So we got 3 times negative 12 plus negative 9 times 21 plus negative 12 times negative 10. And then we're good. Hell yeah. Okay, so, and now we can come back over here. And why is this one, we got the negative 12 back there. And then where did we, I have no idea where we actually even got those values. Because this should be the inverse of A. You know what I mean? Unless this needs to be changed again. Third row, first column. No, that's 15. Yep. My bad on transposing that wrong. I don't even know where I got that. Holy Toledo. Well, I've done this problem a few times tonight. And right now was supposed to be the speed run. But yeah, I think these values are good. You know what I mean? We're fairly close, except that one. And then I'm just going to assume that this column was way off. Oh yeah, I remember that. We were off because of that value. So those were off because of that value. And then we got a little bit tighter. Hell yeah. Do I have another sheet of paper? Yeah, let me rewrite these and we'll find the solution. Alright, hell yeah. And we're just going to do this all in one go. So this is 7 times... This is negative 105. So this scalar is 1 divided by negative 105. So I'm going to take the inverse of negative 105. I'm going to store that in my calculator as x. We might use that. But okay, so we're going to get these values. So negative 66 times negative 5 plus negative 12 times 9 plus 3 times negative 4 divided by negative 105. So this is negative 2. Booyah. Next row, this column, negative 41 times negative 5 plus 21 times 9 plus 21 times negative 4 divided by 105. Negative 105. And we get negative 3. Cool. This row, 15 times negative 2 plus negative 10 times negative 3. Oops, I don't know what I'm doing. It's this row and this column. 15 times negative 5 plus negative 10 times 9 plus negative 15 times negative 4. Okay, and then divided by negative 105, that's 1. Alright, so it seems like we're good to go. How do we check this? Well, we have AX is equal to B. We just found X. This is our solution of matrix, our solution, our vector of unknowns. This is our vector of unknowns. Our vector of solutions. And so when we take this, when we take A times this, we should get that. So let's do that. So we have 1 times negative 2 plus 2 times negative 3 plus 3 times 1. Cool. And what the hell? That did not work. Oh, see. Sometimes there we go, negative 5. Sometimes I do a positive sign instead of a multiplication. And that's the foundational mistakes of matrix algebra. Because you're either multiplying numbers or adding numbers. You know what I mean? And you never have to subtract as long as you're just adding the opposite. But multiplication and addition, if you want to just destroy your brain, do matrix algebra because you'll get them confused. You'll overlap addition and multiplication all the time. It's the worst. Okay, so we have 3 times negative 2 plus negative 9 times negative 3 plus negative 12 times 1. And that's 9. Cool, last one. Negative 1 times negative 2 plus 8 times negative 3 plus 18 times 1. And that's negative 4. Alright, we did it. So that was my speed run, but we did mistakes. So I'm going to try to do this speed run one more time. and try to not make any mistakes. But hell yeah, thanks for joining me, and that's a video.